Romex cable, specifically Type NM cable, is permitted for branch circuits supplying lighting, outlets, washers, dryers, and computers in commercial laundry applications within New Jersey, provided certain conditions are met. Firstly, the cable must be Type NM and sized appropriately for the load it will serve. Secondly, Romex must be installed within walls, ceilings, or other concealed locations for protection. For heating, hot water, and air conditioning loads, Romex is generally not permitted due to the higher temperatures and current requirements typically associated with such equipment. Consult Article 300 of the National Electrical Code, or NEC, and any relevant local codes for proper wiring methods for these loads. For masonry walls, Romex may be used within them if it is protected by conduit or raceways. In sheetrock walls, Romex may be installed without the need for additional protection. All wiring must be installed in accordance with the NEC and local electrical codes. Proper permits and inspections must be obtained before commencing any electrical work. Romex cable must be labeled with its intended use and meet the requirements of Underwriters Laboratories, also known as UL. The wiring method used must be appropriate for the occupancy and use of the space. For example, ensure the cable ampacity is adequate for the circuit's intended load, considering directing factors for ambient temperature or multiple conductors in a raceway, as outlined in NEC Table 310.15b3. Grounding is crucial for safety. All circuits must have an equipment grounding conductor run with the circuit conductors properly sized according to NEC Table 250.122 and connected to all metallic enclosures and equipment. Consider the voltage drop in the circuit, particularly for long runs, to ensure that equipment operates correctly. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% overall. Surge protection may be necessary to protect sensitive electronic equipment from voltage spikes. Consider installing a surge protective device, or SPD, at the service entrance or at individual equipment locations. The NEC provides guidelines for SPD selection and installation in Article 285. For circuits serving motors, such as those in washers and dryers, follow the motor circuit requirements in NEC Article 430. This includes proper overcurrent protection and conductor sizing. Use appropriately rated and listed electrical boxes for all connections and splices. Ensure that boxes are securely mounted and accessible. When penetrating fire-rated walls or ceilings, use fire-stopping materials to maintain the integrity of the fire barrier. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This includes proper cable support, secure connections, and clear labeling. If you are unfamiliar with electrical codes or safe wiring practices, it is always best to consult with a qualified electrician. Improper wiring can create a fire hazard or electrical shock hazard. Ensure that all electrical work is inspected by the local electrical inspector to verify compliance with the NEC and local codes. Remember that local codes may vary from the NEC, so it is always recommended to consult with your local building authority for specific requirements in your area. When selecting Romex cable, ensure it is rated for the appropriate voltage and amperage for the circuit it will serve. Common sizes include 40-2, 12-2, and 10-2, with corresponding ampacities. Always use the correct size breaker or fuse to protect the circuit from overcurrent. Breaker sizes are typically 15 amps for 14-gauge wire, 20 amps for 12-gauge wire, and 30 amps for 10-gauge wire. When running Romex cable through metal studs or other sharp edges, use grommets or bushings to protect the cable from damage. Avoid running Romex cable in areas where it could be exposed to physical damage, such as in unfinished basements or attics, unless it is protected by conduit. When making connections, use appropriately sized wire connectors that are listed for use with the type of wire being used. Ensure that all connections are tight and secure to prevent overheating or arcing. When installing outlets and switches, use devices that are rated for the intended use and location. For example, use ground fault circuit interrupter or GFCI outlets in damp or wet locations. Label all circuits clearly at the electrical panel to indicate what they serve. This will make it easier to troubleshoot problems in the future. When working on electrical circuits, always turn off the power at the breaker before starting work. Use a voltage tester to verify that the circuit is de-energized before touching any wires. Follow lockout-tagout procedures to prevent accidental re-energization of the circuit. If you are working on a multi-wire branch circuit, be sure to identify the neutral conductor and connect it to the correct terminal on the neutral busbar. Avoid overloading circuits by adding too many devices or appliances. Check the amperage rating of the circuit and the total load of all devices connected to it. When installing recessed lighting fixtures, be sure to follow the manufacturer's instructions and maintain proper clearances from combustible materials. Use thermal overload protection on motors and other equipment that are susceptible to overheating. Conduct regular inspections of electrical systems to identify and correct any potential hazards. Keep electrical panels and equipment rooms clean and free of obstructions. Train employees on safe electrical practices and procedures. Provide them with the necessary personal protective equipment, such as gloves and safety glasses. Implement a written electrical safety program that outlines procedures for working on electrical equipment. Follow all applicable OSHA regulations for electrical safety. When disposing of old electrical equipment, follow proper recycling procedures. Avoid disposing of electrical equipment in landfills, as it may contain hazardous materials. Keep accurate records of all electrical work performed, including permits, inspections, and test results. Review and update electrical safety procedures regularly to ensure they are current and effective. When working with energized electrical equipment, use insulated tools and wear appropriate personal protective equipment. Maintain a safe working distance from energized electrical equipment. Be aware of the potential for arc flash and arc blast hazards. Use arc-rated clothing and equipment when working on or near energized equipment. Conduct a hazard assessment before starting any electrical work to identify potential risks and implement appropriate safety measures. Follow all safety precautions when working with ladders or scaffolding near electrical equipment. Ensure that ladders are non-conductive and that scaffolding is properly grounded. Be aware of the location of underground utilities before digging or excavating near electrical equipment. Call the local call center to have utilities marked before digging. Use ground fault circuit interrupters, or GFCIs, on all temporary power circuits used at construction sites. Inspect temporary power cords and equipment regularly for damage. Use only listed and labeled electrical equipment that has been tested and certified by a recognized testing laboratory. Avoid using extension cords as a permanent wiring solution. If additional outlets are needed, install permanent wiring instead. When installing electrical equipment in hazardous locations, such as areas with flammable gases or dust, use equipment that is rated for the specific hazard. Follow all applicable codes and standards for hazardous location wiring. Ensure that all electrical equipment is properly grounded to prevent electrical shock hazards. Test ground connections regularly to verify their integrity. Use only qualified and trained personnel to perform electrical work. Avoid allowing unqualified individuals to work on electrical equipment. Provide regular training and refresher courses to ensure that electrical workers are up to date on the latest safety practices. Implement a system for reporting and investigating electrical incidents and near misses. Use the information gained from these investigations to improve safety procedures and prevent future incidents. When working on electrical equipment in confined spaces, follow all applicable confined space entry procedures. Ensure that the space is properly ventilated and that there is a rescue plan in place. Use portable ground fault circuit interrupters, or GFCIs, on all portable electrical equipment used in wet or damp locations. Inspect portable electrical equipment regularly for damage and remove any damaged equipment from service. Use only approved methods for splicing and terminating electrical conductors. Avoid using methods that could damage the conductor or create a fire hazard. When installing electrical equipment outdoors, use equipment that is rated for outdoor use and that is protected from the elements. Ensure that all outdoor electrical connections are properly sealed to prevent moisture intrusion. Use only approved wiring methods for underground electrical installations. Follow all applicable codes and standards for underground wiring. When installing electrical equipment near swimming pools or other bodies of water, follow all applicable codes and standards for pool wiring. Use ground fault circuit interrupters, or GFCIs, on all circuits serving pool equipment. Ensure that all metal parts of the pool structure are bonded together to prevent electrical shock hazards. When installing electrical equipment in healthcare facilities, follow all applicable codes and standards for healthcare facility wiring. Use isolated power systems in critical care areas to prevent electrical shock hazards. Ensure that all electrical equipment is properly grounded and that ground fault protection is provided. Remember that electricity can be dangerous. Always be safe and follow the electrical codes.